We had two position lines. The vessel was steering 070. There was a southerly current. So we applied the current, allowed for the current, transferred the PL, and we got our required items. The fix at 2130, 2000 hours, course made good, speed made good. So this was the last what we had done. Let's now see the application of this transferring of PL concept with both wind and current in force.
Start falling in place. Now let's take the last example in which we have both wind and current. Same vessel steering 070 degrees true at 12 knots, observes Roche's point light bearing 010 degrees true at 2000 hours, 2130 bore, 320 degrees true. During this period, the current was setting south as in the earlier case at 2 knots and northwesterly wind causing 3 degrees leeway. Find vessel's position at 2000 hours and 2130, CMG and SMG. Before I start plotting, I ask myself few questions. In this case, we have the vessel's propulsion, we have the current, and we have the wind. First, we ask ourselves a question, do we have to allow for wind and current or do we have to counter it? Obviously, your answer would be allowing. Why? Because CTS is known, CMG is to be found. If they have to be allowed, in which order to allow? Please remember your earlier knowledge. You have to first allow for wind and then allow for current. Wind, as explained earlier, can be allowed for on answer sheet. So as seen when we had the wind problem earlier, when we had the wind problem, we got an effective track of 073 degrees true. So in this case also, when you allow northwesterly wind, the leeway track shall automatically be 073 degrees true. So we get going with the plotting, identify the landmarks, draw the PL at 2000 hour, draw the PL at 2130 hours. Take any point on the first PL, that is A. Now what do we draw through A is the effective course of 073. How many arrows do we represent it with? Single arrow. What will be the magnitude of this vector? Engine distance for 1.5 hours, 18 miles. Cut that off and we get point B. Now because it is 073, so wind is already allowed for. Now we allow for current for 1.5 hours, so we draw the current at B, represented by 3 arrows. Drift in 1.5 hours at 2 knots will be 3 miles. We get point C, 180 degrees into 3 miles from B. Now A to C becomes the course made good, and point A is transferred to point C. Why? Because if the vessel was at point A, steering 070 degrees true at 12 knots, experiencing wind and current as given in the question, then she would have done this effective course, and this current would have brought her to C. So point A gets transferred to C. So now we transfer the first PL through point C, mark with 2 arrows, indicate the time, and we get the position at 2130. Draw the CMG through this position, where it will cut the first PL, that becomes the position at 2000 hours. So point Y is the fix at 2000 hours, point X is the fix at 2130, Y to X is the CMG, and distance Y to X is the DMG in 1.5 hours, giving us the SMG. So now we have seen the examples in which we had no wind, no current, then we had only wind, then only current, and now we had wind as well as current. So I hope with these examples, the concept of transferring position line.
Just have a good look at the plot as well as at the question. Let me know if you have any doubts anywhere. All clear, beta?
Yes, okay.
Okay, all right.
Now, the minimum information that was learned by us required to draw a unique circle on a plane surface, and in our context, a unique position circle, is that we need to know or obtain its center and radius. So we need to carry out an exercise which gets us the center and the radius. Thus, transfer a circle, we must only transfer its center. Unlike the transfer of position lines, where we could have taken any point of our choice on the PL and run it up. In case of position circle, we do not have a choice. I repeat, we have to transfer its center and only center. That is, run up its center for the duration required. The transferred PC is then drawn through the transferred center and same radius as the radius of the circle being transferred. The method of transferring the center is the same as what we learned in the method for transferring any point on the PL. The time to which the PC is transferred may be indicated against the transferred PC plotted on the chart.
So just go through these points one by one, beta. Let me know any doubt coming in your mind. Okay, great. The most important thing here in this transfer of position circle is that to transfer a position circle, we must only transfer its center. It is not possible to transfer a position circle through any point on its circumference. We have to apply the run or apply the course steered or the displacement of the ship to the center of the position circle. That is the only point which is available to us. When we transferred a PL, we could have picked up any point on the PL and applied the run on it, and we were able to transfer it. But in case of a circle, the only choice is the center of the circle. Let's move ahead now.
Now, how do we transfer the position circle? Let's list down the steps. First, we need to identify the center of the position circle. The center of the position circle will depend upon the method that has been used or deployed for obtaining the position circle. Imagine the vessel to be at that point, that is the center of the circle. For the duration of transfer, allow the following as applicable to this particular position, that is the center. Ship's propulsion displacement comprising of the course she steered and the engine distance she covered during the interval. Wind allowed for through its leeway and current allowed through its set and drift. The position thus obtained is the transferred center. Now with this transferred center as the center of the circle and same radius as the radius of the PC to be transferred, we draw the transferred position circle.
But any doubt up to here?
सर मतलब जो ये पोजीशन लाइन होती है वहां पे वी कैन टेक एनी पॉइंट फॉर ट्रांसफरिंग बट इन केस ऑफ सर्कल वी कैन ओनली टेक द सेंटर फॉर ट्रांसफरिंग एंड रन अप.
Right, beta, that's right.
Okay.
Okay, let's proceed ahead.
Now, let us quickly review the identification of a center, because as I said earlier, a while back, that the center of the position circle shall depend on the method which has been deployed to obtain the position circle. Now, if we have got a position circle by radar range, then the object whose range has been measured by radar acts as the center. And obviously the range is the radius. In case we have used the concept of horizontal angles, then the point of intersection of the angle arms drawn at the baseline becomes the center of the circle, and the distance from the center so obtained to either end of the baseline gives you the radius of the circle. Vertical angle, object whose vertical angle has been measured is the center, and the range calculated by vertical angle formula that we learned under the position circles is the range. Raising, dipping, first sighting, last sighting of the lights, the center is the light being sighted. And the sighting range, which is lesser of the geographical range and the present luminous range, constitutes the radius. High altitude celestial observations, in case they are applicable to your grade, the GP or the geographical position of the celestial body acts as the center, and the true zenith distance expressed in minutes is the radius of the position circle.
So beta, we have a summary of all the methods which we use to draw position circles, giving us the center of the circle as well as the radius. So any doubt up to here, beta?
So ये vertical angle वाला formula
You don't have that formula, beta?
नहीं सर recollect नहीं कर पा रहा इसलिए.
Okay, let me show you. Take a screenshot and save it with you.
Yes sir.
Just give me a minute. This is the one, beta. Distance of the object in nautical miles is equal to h into 1.854 divided by theta in minutes.
Okay sir.
Okay, let's go back. Any other doubt, beta? Okay, very good. Let's move ahead now.
सर साउंड नहीं आ रही.
Okay, beta, give me a minute.
Now this background to transferring of position circle, let us consider some examples in which we learn how to transfer the position circle.
Is it okay now, beta? Sound?
Yes, sir.
Okay.
At 2000 hours, a vessel steering 250 degrees true at 12 knots observes Ballina-Cotton Island light 5 miles off by radar. At 2045, Roche's Point light bore 000 degrees true. If there was no wind or current, find the position at 2000 hours, position at 2045, CMG and SMG. So no wind, no current, that means CTS and CMG are the same.
So beta, just read the question. Let me know if any doubts are there in the question. Okay, let's move ahead.
Distance made good and engine distance would be same. So first we identify the landmarks. Here is the Ballina-Cotton Island light. This one is the Roche's Point line. With Ballina-Cotton Island as center and radius of 5 miles, that's the radar range. We draw the circle with C1 as the center, and this is the circle for 2000 hours. We have another position line at 2045. That means we have two observations. First one being a position circle, second one being a position line. They are staggered observations. So what we decide is we run up this 2000 hour position circle to 2045. So we apply the CTS at the center. Why? Because we've just learned that to transfer a position circle, you need to transfer its center. CTS is represented by one arrow. In 45 minutes at 12 knots, the engine distance shall be 9 miles. So this is 250 degrees true into 9 miles. We get this point C2 out here. Now, in this case, as there is no wind and no current, obviously this CTS is also the CMG. So we represent it by two arrows on this out here. Now, obviously, in this case, the distance made good would also be the same as the engine distance, and therefore, point C1 is transferred to point C2. So that means the center of 2000 position circle is transferred to C2. With C2 as center and radius of 5 miles, that was the same as the radius of 2000 hour circle, we draw the transferred position circle. The green circle, which has now come up on the chart, is the transferred position circle. That means at 2045, the vessel would be somewhere on the green circle. At 2045, the question also gives us a position line where Roche's Point light is bearing 000 degrees true. So we plot the 2045 PL. We have a 2045 PL and a 2045 position circle, where the two intersect, that is point Y, becomes the position at 2045. Obviously, in reaching position Y, the vessel would have made good a course, which is represented by C1, C2. So the CMG C1, C2 is transferred through Y, and magnitude also is equal to C1, equal to the magnitude of C1, C2. Now where this cuts, the 2000 hour circle that is at point X, that becomes the fix at 2000 hours.
So beta, is this plot clear? Have a good look at it and let me know if there are any doubts.
सर अगर सर ये लाइन सर ये सर्कल को दो जगह पे अगर काट रही होती इस केस में तो सर उसमें कुछ दिया होगा ना सर क्वेश्चन में कुछ और भी हिंट.
Right, beta, you are right. It is possible that a position line and position circle may cut at 2 points and both could be the position of the ship. In this case, तो एक point जो है वो rule out हो गया because it goes on land. But if this happens, then there will be some hint in the question which tells us which out of the two is our actual position. Some hint they have to give.
ट्रांजिट बेयरिंग के केस में हो जाएगा सर.
I didn't get you better.
सर ट्रांजिट बेयर में जो एंगल 180 रहे तो 2 टाइम कट होके सर्कल.
Yeah, that's right. It is possible that it may cross the circle, cut the circle at 2 points. So they will certainly give us a hint which one is correct. Okay, let's move.
Needless to say, point X is the 2000 hour fix, point Y is 2045 fix, X to Y is the CMG, and magnitude of X between X to Y, or distance between X and Y, is the distance made good in 45 minutes, from wherein we can convert it to distance made good in 1 hour, thus getting the speed made good. Now we take the same example, but now we introduce only wind. At 2000 hours, a vessel steering 250 degrees true at 12 knots observes Bellinacotton Island light 5 miles off by radar. At 2045 hours, Roche's Point light bore 000 degrees true. If the vessel experienced northwesterly wind causing 3 degrees leeway, but no current, we need to find the two positions, CMG and SMG. First, we allow for wind. It is allowing for wind. Why? Because we know the CTS, we have to get the effective course.
So the entire question is the same, which we just now saw the plot. Only difference is now there is a wind in the area. So when we are transferring the position circle, we will have to count for that wind.
So I'm sure we are all thorough with the wind, allowing for wind. If you're thorough, then you could skip this step and the allowance could be made in the answer sheet. But let us still have a look at it. This is the CTS of the vessel, 250 degrees true. Wind is northwesterly. Now the leeway shall be allowed to the lee side, that means to the port side. So we allow the leeway to the downwind side, and we get this as the effective course represented by single arrow. What do we see? Effective course or the leeway track is 247 degrees true. In this case, the leeway got subtracted.
So is this clear, beta?
Yes, sir.
Okay, great. Let's move ahead.
The same thing you can see in the box now. We could do in the answer sheet through these 3 simple steps. CTS 250 degrees true. Leeway 3 degrees northwesterly wind. As I said earlier, wind, direction, and the CTS have to be considered together to decide whether to add or subtract. So the effective course becomes 247 degrees true. Now, instead of drawing the CTS on the chart, we'll now draw the effective course or the leeway track, and the magnitude of this would be same as the engine distance in 45 minutes. So we plot it here now. So we have this as the Bellicotton Island light. We have the Roche's Point with C1 as the center and the radius of 5 miles. We draw the position circle for 2000 hours. Now to transfer it to 2045, we need to transfer C1. Since we have already allowed for wind and got the effective course as 247 degrees, we draw 247 through C1, represented by single arrow. On this, we mark off engine distance for 45 minutes. That's 9 miles. So 247 degrees into 9 miles, we get point C, C2. That means now C1 is transferred to C2 because there is no current in this question. So with C2 as the center and 5 miles as the radius, we draw the transferred position circle. Why? Because C1, C2 is also the CMG, and C1, C2 is also the distance made good. So we draw the transferred position circle. green position circle is the position circle. Green position circle is the position circle for 2045. Now we draw the 2045 PL. This is 2045 PL, where the two intersect here. That is the position point Y. That is the position at 2045. Now we transfer C1, C2, both in direction and magnitude through Y. And where it cuts the 2000 hour position circle, this point X is the position of the vessel at 2000 hours. So X is the position at 2000 hours. Y is the position at 2045. X, Y is the course made good, and XY distance is the distance made good in 45 minutes, giving us the.
So is this plot clear, beta? Any doubts in the plot?
No, sir.
Okay, very good.
Speed made good. Now we take one more example wherein there is no wind but only current. At 2000 hours, a vessel steering 250 degrees true at 12 knots observes Ballina Cotton Island light 5 miles by radar. At 2045 hours, Roche's light bore 000 degrees true. If the current was setting south at 4 knots, but no wind, we have to find the two positions, CMG and SMG.
So beta, exactly the same question what we did earlier. Only difference is now this time we are having current in the area. So we will be transferring the position circle, allowing for the current.
Since the current has to be factored, we ask a question, counteracting or allowing. CTS known, CMG to find. So obviously it's allowing. So we basically first draw the first position circle, both landmarks identified with C1 as center, 5 miles as radius, we get the 2000 hour position circle. Now we have to run up C1 by 45 minutes, and we have to basically, we have the ship's propulsion displacement and current has to be allowed for. So we first draw the CTS of 250 through C1, single arrow, 45 minutes engine distance shall be 9 miles. We cut off that point and we get point A. A would be the DR, not really DR because the ship is not at C1. So, but if the ship was at C1, then she would have reached, the DR would be A. Now we allow the current at point A, which is the arrowhead end of the CTS line. So southerly current is allowed here, represented by 3 arrows. Now, if the rate of current is 4 knots, drift in 45 minutes shall be 3 miles. We cut off 3 miles, we get point C2. C1 to C2 is now the course made good, and C1 to C2 is the distance made good in 45 minutes. Now, with C1 as the center, C2, so I'm sorry, with C2 as the center and radius of 5 miles, we draw the position circle. That will, the green one is the transferred position circle. That means the vessel shall be on the green position circle at 2045. Now we draw the 2045 PL through Roche's point, where the two intersect, that is point Y, is the 2045 fix. Through this, we draw C1, C2 through 2045 position, and where it cuts the 2000 hour position circle becomes position point X, and that is position at 2000 hours. X is the position at 2000 hours, Y is the position at 2045, XY is the CMG, and XY distance is the DMG in 45 minutes.
So have a good look at the plot, beta. Let me know any doubts coming in the mind. Okay, good. Let's proceed ahead.
In all these three examples, we had taken a combination of one position circle and one position line. Now let's take the last part of it. At 2000 hours, a vessel steering 253 degrees true at 12 knots observes Tusker Rock Light first sighted on its starboard bow at a range of 3.5 miles. At 2030 hours, Tusker Rock Light was last sighted at a range of 5 miles. If the current during this period was setting south at 4 knots and northwesterly wind caused a leeway of 3 degrees, we need to find position at 2000 hours, position at 2045, course made good, and the speed made good.
Beta, just go through the question carefully. Let me know anything which is not clear. Now, sometimes people get confused in these type of questions. So be a little careful. Let's proceed slowly. Okay, let's move ahead.
Now, in this case, we have two position circles. One position circle at 2000 hours where Tusker Rock Light was first sighted. That means it shall be drawn with Tusker Rock Light as the center and first sighting range of 3.5 miles as radius. At 2030, we get another position circle with Tusker Rock Light as the center and the last sighting range of 5 miles as the radius. So if we want to use running fix in this, we can run up the 2000 hour position circle to 2030 and we can get the positions and the required information. Now, in this case, since we have to allow for both wind and current, so as we have already know, we first need to allow for wind followed by current. As far as allowance for wind is to be made, it can be made on the answer sheet. So CTS 253 degrees true, you can see the yellow highlighted information. Leeway 3 degrees northwesterly wind. So that means the wind is from the starboard side. Port side is the lee side or downwind side. So leeway will have to be subtracted. So the effective track or the effective course or the leeway track will be 250 degrees true. So when we have to allow for both wind and current, we allow for wind ideally on answer sheet and we use the effective course to plot. So now we first draw the 2000 hour position circle. We identify Tusker Rock. This is C1 with C1 as center and first sighting range of 3.5 miles acting as radius. We draw this position circle blue one. This is the position circle at 2000 hours. Now we have to run this circle up by 30 minutes to transfer it to 2030. That means we'll have to transfer the center C1. So we draw the effective course through C1 represented by single arrow. Now ship is doing an engine speed of 12 knots. So in half an hour, the engine distance shall be 6 miles. So we mark of 6 miles on it, we get this point A. Now wind allowed for, now is the time to allow for current. By now we all know where is the current to be plotted. The current is to be plotted at A. So at point A, we plot the current and this current is plotted at A southerly, represented by 3 arrows. And since the current set is, rate is 4 knots, in half an hour it will be 2 miles of drift and we get point C. That means C1 to C2 is the course made good and C1 to C2 is the distance made good in half an hour. In other words, C1 gets transferred to C2. So now with C2 as center and same radius of 3.5 miles as that of 2000R EC, we draw the transferred position circle, which is now shown here by the red position circle. So this is the transferred position circle for 2030. At 2030, we have another position circle, which can be drawn with Tusker Rock Light as the center and the last sighting range of 5 miles as radius.
Beta, up to here is clear. Up to here, we have just transferred the 2000 position circle to 2030.
Yes, sir, all good.
Okay, all right. So we are now going to mark off the 2030 position circle.
So we draw that position circle. The green position circle is 2030 position circle obtained by using the last sighting observation of the Tusker Rock. So now this green position circle is for 2030. The red position circle is transferred circle for 2030. Now where they intersect? Now they intersect at this point out here, and they also intersect at this point. Now these two could be the possible positions of the vessel at 20-30 hours. Now in this case, we can see that this northerly position is in non-navigable waters, so it gets ruled out. So this one out here is the position of the vessel at 2030. This is 2030 position. Now we draw C1, C2 through this X and equal in magnitude, and where it cuts the 2000R position circle, we get point Y, which is 2000R position. Additional information given in this question to rule out the possibility was that only at 2000 hours, if this was the position at 2000 hours, then only the Tusker Rock would be on starboard bow. Had this northerly been positioned even in the navigable waters, then its corresponding position at 2000 hours would have Tusker Rock on her port side. So therefore, this point Y is 2000 hours position circle, X 2030 position circle, XY the CMG, and distance XY, the distance made good in half an hour, double it up to get the speed made good.
So beta, meditate on this plot. Let me know if you get stuck anywhere. All good beta, under control?
सर ये ग्रीन वाला सर्कल बताना एक बार कौन सा था?
ओके देखो बेटा, एक तो यहाँ पे 2000 आवर्स पे हमें पोजीशन सर्कल मिला है विच वॉज एट ए रेंज ऑफ 3.5 माइल्स. हमने ये जो ब्लू कलर का सर्कल बनाया है, ब्लू कलर सर्कल, दैट इज दिस 2000 आवर्स पोजीशन सर्कल. देन एक पोजीशन सर्कल हमें मिला है 2030 पे एट ए रेंज ऑफ 5 नॉटिकल माइल्स. जो ये ग्रीन कलर का सर्कल है, दिस इज द सर्कल एट 2030 आवर्स विद ए रेंज ऑफ 5 माइल्स. So Tusker Rock is the center, 5 miles is the radius, and this green circle is the position circle for 2030.
Okay, sir.
Okay. और बताओ बेटा, doubts?
इस वाले क्वेश्चन में ये दोनों पोजीशन सर्कल ड्रॉ करने हैं या सिर्फ ट्रांसफर वाला कर लें तो चल जाएगा?
बेटा आप अगर चाहो तो 2000 आवर्स का जो ब्लू कलर का पोजीशन सर्कल हमने बनाया है, नहीं, इसे भी आप नहीं छोड़ सकते. आपको ये तीनों ड्रॉ करने पड़ेंगे बिकॉज
पोजीशन नहीं आएगी लास्ट.
राइट. वैसे तो बन जाएगी पोजीशन, ऐसी बात नहीं है. आप अगर अपना मैग्नीट्यूड C2 C1 के जितना ड्रॉ करोगे तो वाई पॉइंट तो आ जाएगा, but it needs to be shown on the circle. So that's why better you make all the 3 circles.
Okay, sir.
Or beta, any more doubts coming? Okay. So with this, basically we finish off the transferring of the position circle. We saw different scenarios with wind, with current, and in this case, both wind and current together. So all the scenarios for transfer of position circles are covered up.